ahead and get started? Okay, great. Okay, why don't we get started? First of all, I want to thank you all for joining the presentation today. My name is Mark Rude. I'm the head of strategy and marketing for VNS, Veolia Nuclear Solutions. And the topic of today's presentation is on what's a very exciting project for us, or technology for us, and that is our geomelt thermal treatment process for the treatment of radioactive and problematic waste streams. So in the presentation, I'll cover briefly the technology itself, but what I will specifically talk about is a project in the U.S. for treating reactive metals, a project that we had done in the United States that in fact we won yesterday. Happy to announce the Product and Services Award at WNE yesterday during the award ceremony. So let's get started. First, just to introduce a little bit about VNS and cover the different business lines that we have, or the different business pillars. We are broken down into three business pillars. The first of which is on-site services, which is related to facility maintenance or facility services, operation and maintenance, and decommissioning remediation of existing plants. Primarily done in the U.S. for the Department of Energy, but also done here in France as well through our Astralis subsidiary. The second pillar is our technology pillar. In that area, we have robotics or remote handling applications, mainly what we're doing at places like Fukushima to remove fuel and clean up the site there currently, as well as our treatment technologies, which geomelt falls into this category specifically, and our nuclear measurement capability. The third pillar being waste management, which covers our treatment, decontamination, material processing at licensed facilities that Veolia manages. And so in regards to this presentation, what we're going to cover is the two areas. One from technology, which will be geomelt, which I'll cover here in more detail. And the second of which is the waste management business line, which is truly the treatment aspect of using the technology to treat various waste streams. So before we get into geomelt, let's talk a little bit about vitrification and talk about the value of vitrification and why it's important. It's important to note that vitrification in the nuclear industry is the gold standard for treatment. And why is that? It simply provides the most stable form to allow for radioactive decay over time, which is our friend in this industry, obviously. Being able to stabilize waste in a durable glass form that lasts for thousands of years and is resistant to leaching is why it's important. It's also a robust process that significantly reduces the volume of waste compared to other methods. And so one example of that is, I know it might be hard to see on the screen, but is to take an example of waste that we have at Fukushima that will be treated, and in this case, spent media that was used in the decommissioning, the water treatment process after the accident, where you have a little over 9 meters cube of waste. If you take that waste and you were to cement it, you have approximately 9 boxes of waste, versus if you were to vitrify it, you come away with 1. So that just gives you an idea of where the volume reduction comes into place and the advantages of vitrification. So now let's talk a little bit about geomelt. But first, it's important, I guess, to talk a little bit about the history. Geomelt was actually invented in the U.S. by the PNNL, the Pacific National Laboratory in the U.S. near the Hanford site back in the early 80s, long time ago. It was commercialized in 1993. There was a period of technology advancement, mainly for what we call in situ vitrification, so treating contaminated soil in the ground through the process. That technology continued to develop and mature to the point where then it transitioned to a secondary processing step, which we call in-container vitrification, or what we do more commonly now is melting waste in a box. Okay. In 2016, Veolia acquired the technology, and what happened after 2016 is an acceleration period. So we recently commissioned a facility, or a system in a facility in 2018 to treat reactive metals, which is the topic I mentioned that we won the award for yesterday. and we were happy to announce that we'll have another system by Q1 of 2022, site to be announced later, but another facility in the US, with the hopes and the idea that we then grow that technology and being able to implement the same philosophy, blueprint, if you will, into the UK and French market and Japan market in the future. One big aspect of our company, Veolia, we invest very heavily in R&D. We invest very heavily in our IP portfolio to continue to refine the process, make it better, find different ways of treating various waste streams, especially the more complex waste streams. And now we'll show a quick video here just about the process itself and what GeoMelt has to offer. So it is a GeoHeal method process. You'll see some pictures, but what we use is electrode feeders that go actually into the melt box itself or into the ground itself to joule heat the waste or the area that may be contaminated. In this case, you see the box itself here. We can treat anywhere from low-level problematic waste to higher level waste. So what do I mean by that? Sodium contaminated waste is the project that I mentioned earlier, but we're also treating and testing our different waste recipes or formulas for treating higher level activity waste, such as that at Fukushima for cesium contaminated waste in the media that I mentioned earlier. So that is an example of the in situ vitrification or in-ground, mainly used for contaminated soils. And it is a robust process. It's a proven process. So 26,000 metric tons of waste have been processed to date. About 50% of that has been radioactive material. So not everything has been radioactive. Some has been hazardous waste material as well. So I mentioned the volume reduction, the advantages of that are you can get up to 80% volume reduction. Not only that, but once you do get that reduction, you can actually reuse that same box so you can get full capacity in your waste package before disposal. Okay. So here's another picture just showing some of the advantage of that, the two methods again for vitrifying waste. And then if we look at the benefits, again, broad temperature range for different materials, for different waste types that we can dial up, dial down in order to treat. Mentioned the volume reduction, 10 times stronger than concrete. So why does that come into play is because it remains a stable waste form for much longer. I mentioned the amount of waste we've done to date. Another important aspect is this system that we've developed can either be mobile or fixed base, meaning it could be in a merchant plant facility or be able to be transportable depending on the type of waste that you're treating. Okay. So here's just an example of the two different methods that we have, the in situ versus ICV. The higher level activity waste that you have, you can actually contain the material in a box that can either be reusable if it's lower level waste, versus higher level waste, the waste package itself can be the container that is actually disposed of and act as a shielding as well. Okay. So talk about our specific systems. Point out the picture at the top right. This is the first system that I mentioned that we commissioned in 2018 in the US to treat sodium contaminated waste. It's located in Richland, Washington at the Perma-Fix facility that we're partnered with. You see the planned GeoMelt systems for low-level waste, both in the US, I mentioned by Q2 we'll have a secondary system. In the UK by 2024, and in France by 2026 is our strategy. Okay. Once we have proven that process and we've adapted that process to be able to look at more challenging waste forms, such as that at Fukushima, such as that in the US in Hanford for instances of Hanford tank waste, we'll be able to adapt that to on-site systems, and we're currently very active, especially at Fukushima, for treating the secondary waste that I mentioned from the water treatment process from nearly 10 years ago. So now to talk about the project yesterday that I mentioned, we won the WNE award for product and service in terms of innovation in technology. So this project was to treat sodium contaminated waste, metal waste. Our client is Battelle Energy Alliance, which is located at the Idaho National Laboratories. A very good client, a very good team partner. The waste that was generated came from their reactor program at INL. It produced alkali medical waste without a well-defined treatment option. So it's been sitting there, it's been stored there without a good treatment option. GeoMelt, through various testings and through various bench scale testings and analysis, proved to be a good option for this waste. So we addressed that problem with the GeoMelt technology, and we designed and built the system, commissioned it in 12 months. That was it, so very quick. The very first waste inventory that we handled were 55-gallon drums or 208-liter containers of sodium contaminated material. To date, we've melted, or we've done nearly 1,000 drums to date. There's other waste streams to follow, things that are called the zipper plates. You see some pictures of the different waste materials, sodium contaminated traps. So there's a variety of different waste forms that the system can treat. And the other advantage is that you can actually melt the metal waste along with the sodium in a single melt without separating it. So now let's talk a little bit about our other facilities that we have. By 2022, we will have 6 facilities of different capacity, different scale to be able to test, bench scale, or in some cases actually treat the waste. I mentioned the ones in the US. We have an additional one in the US that is purely for bench scale testing in Richland called Horn Rapids. It's worth mentioning the system that we have at NNL in the UK is available too. I'll talk about LeMay here in a minute, but that's the newest facility or the newest system that we've developed and implemented. And then Daikenkyo in Japan is a hazardous waste facility that there's a GeoMelt that's active in treating mainly contaminated soil in country. So a little bit about LeMay, because it is in France and it is the most recent system that we've commissioned. It's located at Veolia LeMay plant that is run by Sarpi, a sister company to VNS for treatment of hazardous waste for incineration, cementation, and other processes. So we've been able to piggyback on that facility and implement our GeoMelt system that you see here to be able to have a pilot system that enables us becomes a catalyst to be able to treat and evaluate different recipes for waste, not only in the UK market, French market, but also the UK market as well. And so why is that important? Well, if anybody heard yesterday, we signed a joint venture agreement with our friends from EDF, a new joint venture called Waste to Glass. And so the Waste to Glass entity will be used as really the catalyst or the vehicle, you will, to be able to evaluate and look at different types of waste streams, utilizing the LeMay capability to be able to test these different waste forms and address the market needs. So just in conclusion, reiterate that the success of the GeoMelt project, or I should say VNS is benefiting from the success of the GeoMelt project in the US. It truly was a benchmark project for us to be able to validate that it is a viable technology. It is credible, it's proven to be able to treat these types of waste forms in the industry. It has certainly helped us in Japan to pursue Fukushima waste. It's certainly helping us in the UK and France to pursue our strategy here as well. But as the case with any project for us, alliances or partnership is key. I already mentioned Waste to Glass. I mentioned Battelle Energy Alliance. None of these things can happen without partnerships. We specialize in technology. That is what we can bring to the table. We have the experience, we have the expertise, but having those alliances and those partnerships for your different waste streams is what makes it work. Okay. The market is large. There's problematic orphan waste streams that are out there that need to be treated, that need to be evaluated. So the need for geomelt or geomelt's position within the market is a good one. It's not the only one, but it's certainly part of the solution. And so really what the final question is, it's not a question for me, but for everybody, is what are your waste problems? What waste problems do you face in your markets, whether it's in France, UK, or elsewhere? And is geomelt a viable candidate to be able to process that type of waste? So I appreciate the time. We're happy to answer any questions that you may have. We welcome you to our booth. We have a lot of material, videos, models of the geomelt system if you have specific questions, and we welcome you all to join us. Thank you.